Okay. I'm audible, right? And the screen is visible, right?
Yes, ma'am.
Okay. That's what. In the last class, I've given you a homework to draw the class diagram for a case study. How many of you have done it? At least, do you remember what's the homework given to you?
Yes, ma'am.
Have you done it? Anybody, at least one or two solutions?
Yes, ma'am. I've given it a try.
Is it possible for you to show me or share your screen? Should I make you the presenter, Abhishek?
Uh, Actually, I've done it on a notebook, ma'am. It's not very clean.
All right.
I can tell you the number of classes and the attributes. Like,
Okay. Uh, Tell me, how many classes you have designed in your class diagram or you have identified in your class diagram?
okay, so I have identified 1, 2, 3, 4, 5, 6, 7, 8 classes.
Eight
Uh,
classes. What
the
are they?
main one is library. Then
Library,
library has a book, and it also
okay,
has a user.
user. These are
Then,
the member variables, is it?
no, they're aggregate classes, aggregation
Aggregate
relation.
classes. Okay, fine. That means book is also a class, user is also a class.
Yes, yes.
Okay, all right.
Then
What are the member variables of this library class, Abhishek?
uh, I don't think library class has any member variables, but it has
Functions, member functions,
I okay, no, I don't think library class has anything for that matter. It just
okay.
has
Aggregate
aggregate class.
classes. Okay,
Yeah.
okay. Next,
Then book has title, author, publisher, and catalog number.
as member variables.
Yeah,
Okay.
and respective setter and getter methods.
Hmm.
Then book has an aggregate class copy,
Hmm.
which has copy number, edition, publisher number, ISBN, and book status,
Okay, okay.
and all the respective getter and setter methods.
Fine. Good. Then.
Then we'll go to the library aggregate class, which was user.
Hmm.
Then user has inherited classes, as in is a relationship.
Okay.
So faculty, graduate, and undergraduate, all of
Hmm.
them have is a relationship with user.
Okay.
Then user has name, address, telephone number,
Hmm. User ID.
and yeah,
Hmm.
yeah, and the get all of them have their respective getter and setter methods. So I won't,
Exactly. Good.
yeah.
Huh.
And faculty has the extra office address and office telephone number.
Hmm.
Then the graduate class has graduate program and advisor info.
Hmm.
Undergraduate class has program and total credit hours.
Hmm.
And I was a bit confused about the loan part of
Okay.
the library. So I put it under an aggregate class of user. So user
Correct.
has a loan,
Hmm.
and the loan has copy number of the book, title
Hmm.
of the book, and the
Hmm.
author.
Okay. Okay. Yes. And there are some more additional members you can include actually because see users can borrow books, right? Other than get and set functions, users
Mm.
can also borrow books. So borrow book could be a member function for user. Similarly, in the statement or in the case study they've mentioned faculty can view journals and so on, right? These are all the additional functionalities a class can have. Okay, so apart from get and set functions, you can think of these additional functionalities like borrow books, view journals, and so on. Okay, and what you did is right. Fine. And when you are drawing a class diagram, make sure of including the proper relationship. Okay, whether the relationship
Yes.
is a relationship, has a relationship, or uses a relationship. You know, we use something called as a diagonal arrow for has a relationship or part of relationship and so on.
Yes, ma'am.
And
I've done all that notation.
okay, okay, good, good,
Yeah.
Abhishek, good. Okay, anybody else tried this? Any other solution? No? If you try it, it's a practice for you. Okay, appreciate Abhishek. He has tried. Okay, all right, let's proceed with today's class. We have discussed about relationships in the last class. So I will just give a summary of the same. What are the types of relationships you have in OOPS or object-oriented concepts? If anybody could just recall what was discussed in the previous class, it would help you to understand today's class. What are the types of relationships we have discussed?
Ma'am, we have inheritance,
Okay.
aggregation, and association.
Okay. We have inheritance, that is a relationship, and we have has a relationship, or in other words, it is association, is it? And we have uses a relationship, right? So there are three relationships, and the case study is also given to you that bank is providing the loans and there are different types of loans, etc. So the example has a relationship is aggregation, uses a relationship is association, and this example or this case study also we have discussed, right? The loan, there are multiple different types of loans, and housing loan is a type of loan, personal loan is a type of loan. So that is a relationship is called as inheritance. That means housing loan will be a subclass of loan class. Okay, we call it as a base class and derived class. Housing loan is a derived class and loan is a base class, or loan class is a superclass and housing loan is a subclass, or loan is a parent class and housing loan is a child class. Any terminology can be used. Okay, and has a relationship is a aggregate. Okay, housing loan has property details, you include property details in housing loan class. Similarly, you include the details of address class in property details class. That is a kind of aggregation, and the reverse of it is part of relationship. And again, uses a relationship, uses a relationship is loan advisor for providing the loan should use loan class. It's a kind of loosely coupled relationship. So the example also we have discussed, right? Housing loan and loan. When you are using a is a relationship, the child class or the derived class uses the properties of its parents class. Plus the child can have additional functionalities. Okay, it can have additional functionalities, but it extends the base class. Fine. That means all the functionalities of loan class are included in housing loan class. Plus the housing loan class can have an extra or additional variable or additional functions. That is a kind of is a relationship. Next, has a relationship is having the aggregate functions or aggregate classes included in a class. And this is an example. For the same, you can see how they are included. In housing loan, the last member variable is the inclusion of aggregate class, that is property details, which is a property details class you are including. Similarly, property details has the address class, okay, as one of its member variables. Fine. And you can see the usage of a diamond box there. Fine. That is how you should represent when you are drawing or you are designing a class diagram. Okay, relationships should be clearly mentioned or shown in the diagram. Next, you have uses a relationship. It is a kind of interaction between the classes. Okay, one loan advisor could contact any number of loans based on the based on the conditions to give a loan to the customer. Fine. Next, the multiplicity. We have discussed 3 different cases, and it is basically used for aggregation and association. We do not use any multiplicity when you are including inheritance. Okay. Inheritance you cannot represent multiplicity, but for aggregation and association you can associate them with the help of this one to many or one to one or one to many association. Fine. One to one association is similar to like one car has one engine, right? One car cannot have multiple engine, and engine is mandatory for the car to run. Fine. So it is purely one to one relationship. Similarly, or one-to-one aggregation. Fine. One car has one engine. Next comes one-to-many aggregation. One person can have multiple credit cards. Okay. Or a person has 0 or more credit cards. It's a kind of one-to-many aggregation. And the last one is one-to-many association. Okay. One customer should have or uses one or more bank accounts. He cannot have 0 bank account for him to be a customer of that bank. He should have at least one bank account. That is why customer can use one or more bank accounts of a particular bank. Okay, so that is association, one to many association. So these are the multiplicities you are supposed to mention when you are going with the class diagram and you are representing aggregation and association. Okay. Next, to continue with the relationships, we have, let us study each of them in detail. Okay. We have an important one called inheritance. Fine. You have a class called loan class. Fine. You have a loan class, and in loan class you have loan number. Just a minute, just a minute. Sorry for the break. Okay, I had a visitor, so sorry for it. And okay, we were discussing about this inheritance. We have a loan class, say, and we have another housing loan class, which you can see in the diagram. As I said, loan class, in case of is a relationship, when loan class is a loan, housing loan class is a loan, fine. Housing loan will become the derived class and loan will become the base class. Okay, or in other words, a parent and child relationships. Okay, this housing loan class, see, there are 4 attributes in loan class. You can see it in the diagram, right? There are 4 attributes or 4 member variables in loan class, and there are 8 functions, member functions in loan class. So when housing loan class is a loan class, or it is having inherited or inheritance relationship with the loan class, what happens to housing loan class is, of course, it will get all the member variables and member functions of loan class. It inherits all the functionalities of loan class, plus it has an additional member called interest type. So there are already 4 members of loan class. So which housing loan will inherit, plus there will be a interest type or one more additional attribute. So there will be 5 attributes for housing loan class. 4 it inherits from the parent and 1 it can have its own. Similarly, when it comes to member function, 8 it inherits from the parent class and 2 it has the additional, any number of additional features it can have. Okay, but it inherits all the properties of its parent class. Okay, so you can see the explanation also, you can read it. Multiplicity applies only to aggregation and association. It doesn't apply to either relationship. Okay, you cannot represent the multiplicity for either relationship. It is only for aggregation and association. Inheritance refer to a class replicating some features or properties from another class. Okay, it can use or it can represent some of the features. Of course, it can use all the properties of loan class or it can use whatever is required from the loan class. Fine. So inheritance allow definition of definition of new classes on similar lines of base class. See, the base class and derived class cannot be totally unrelated, right? When you are inheriting, when you are using either relationship, somewhere they should be connected, fine. Loan and housing loan are connected. That is why I can have it. Okay, I can have either relationship among them. The class which inherits from another class is called as derived class. That is, housing loan is inheriting the features from loan class. Hence, housing loan becomes the derived class and loan becomes the base class or the super class or the parent class. Okay. So look at the example here. Housing loan class inherits from loan class. So need not redefine member variables and methods defined in parent class. You do not have to redefine loan amount, interest rate, duration, customer ID and so on in housing loan class because it is already defined in loan class and housing loan inherits loan class, right? So the redefinition of the member variables used in the loan class in the housing loan is not required. Similarly, the methods, fine. When you inherit, automatically you get the access to the member variables and member functions of its parent class. So redefining them in the derived class doesn't make any sense, fine. So loan is a base class, housing loan is a derived class. Next comes the concept of protected access specifiers. We have in OOP or object oriented concepts, there are 3 types of access specifiers. One is private, one is public and one is protected. Private access specifiers, the member variables or the functions which are considered to be private are private to a class. Okay, private to a class. They are not accessible anywhere outside the class. But when the access specifier or when any member variable or member function is public, they are accessible everywhere. Okay, any class can access them, any class can use them. But when they are considered to be protected, fine, in the absence of inheritance, they behave like private. Okay, when you make any of the member variable as protected, fine, and if your program has no either relationship, if there is no inheritance in your program, then these protected access specifier behave like private. Okay, but when you have the derived class in your program, that is when inheritance is used in your program, then member variables are accessible to the class where they are defined plus the class which inherit that particular base class. Okay, suppose if there is any variable in the loan class which has protected access specifier, and if there is a housing loan class which derives the loan class, then that protected access or protected variable inside the loan class is accessible to its derived class, that is housing loan class. Okay, so that is why in the beginning when we were discussing about access specifier, there was a line stating that protected access specifier is similar to private in normal circumstances, and we will discuss its other what we say, the features or the properties later on It is basically used, the protected access specifiers have their importance when inheritance is used in the program. Okay. So protected members are accessible to the base class and their derived classes. There are two important types of inheritance you are supposed to remember. One is multi-level inheritance and other one is multiple inheritance. Okay, this is basically the hierarchy levels. Okay, hierarchy levels, and that decides what type of inheritance that is to be used. Fine. The class can inherit from another class, and derived class inherits all the members of base class. You know it, right? There is one base class, there is one derived class. So derived class inherits from the base class. Fine. It inherits all the properties of base class, and this derived class acts like a base class for another class. Okay. So another class can inherit from the derived class. It's a three-level hierarchy. Fine. Loan is a base class for business loan class, and business loan class is a base class for large business loan class. A three-level of hierarchy. Okay. So loan is parent for business loan and business loan is parent for large business loan. Fine. So what happens when you do this is business loan inherits all the properties of loan class, right? It inherits all the properties of loan class. Large business loan inherits all the properties of business loan class. In turn, large business loan class inherits all the properties of loan class as well, because loan class, the details, the properties of loan class is included in business loan class also. So when large business loan class inherits business loan, of course it is indirectly inheriting, or it is indirectly using using the properties of loan class. Okay. So that is a kind of multi-level inheritance, multiple levels of inheritance, not just one base class and one derived class, instead any level of base and derived class hierarchy. Fine. So that is about multi-level inheritance. Any doubt here? When you represent a derived class, okay, you do not try to redefine the properties or the member variables and member functions of its parent class. Okay, they will be automatically inherited to the derived class, so there is no need of redefining them in the derived class. Here the derived classes are business loan class and large business loan class. So business loan class is a derived class of loan class. So it is not required to include the member variables and member functions of loan class and business loan class. Similarly, large business loan class is a derived class of business loan. So the interest type and term of business loan you do not have to redefine in large business loan class. Okay. That is about multi-level inheritance. Sorry. Next comes the concept of multiple inheritance. Okay, multi-level is multiple level of hierarchy. Multiple is one class inheriting more than one base class. Okay, so a child inherits the properties of both father and mother. If father is one class, mother is one class, child is another class. Child will be a derived class and there will be two base classes, mother and father. Okay. So child inherits the properties or the features or the qualities of father as well as mother. So there will be two base classes and one derived class. Okay. Of course, child can have the additional qualities, but it inherits some qualities of mother and some qualities of father. Okay. This is a typical example of multiple inheritance, and you can easily remember it. And there could be another example like a hybrid car inherits from fuel car and battery car. It can be anything, right? Fuel plus battery. Okay. So some properties of fuel car, some properties of electric car will contribute to a hybrid car. That is another example of multiple inheritance. Okay. So it is actually so much of confusing to use multiple inheritance. Okay, when you use it, what properties to inherit from what class, there are a lot of complexities involved when you really implement multi-level inheritance. Fine, that is the reason multiple inheritance is not used in modern OOP languages. Okay, OO languages, it is used in C++, but after C++, Java and C hash do not support this multiple inheritance. Okay, this is just a template of how to represent inheritance in code. Okay, you know how to define a class, right? You write class, C should be small case. Okay, name of the class, and inside that curly bracket there will be two sections. First section is member variables and second section is member functions, right? And when you are extending or when you are using is a relationship, when housing loan is a derived class of loan, you write class housing loan extends loan. Extends is a keyword used during inheritance only. Okay, the meaning is simple. Housing loan is a derived class of loan. In the sense, housing loan uses all the functionalities of loan plus its own functionalities. So it is an extension of loan class. Okay, extension in the sense the features or the properties of loan class will automatically come to the housing loan class, plus it can have some additional functionalities. So extends is a keyword used for inheriting a class. So housing loan class inherits loan class. That is why we write housing class housing loan extends loan. Okay, so whenever you are creating the classes, if the class you create inherits any other class, then you use the keyword extends. It is very important to use those keywords for some specific concepts. Okay, extends is a keyword used for inheriting or inheritance. Next comes the concept of generalization and specialization. Any doubts so far?
No, ma'am.
Okay. So, generalization and specialization. Uh, when you implement this concept of inheritance, okay, in any object-oriented solution, when you design the concept of inheritance, you have to first identify the similarities among the multiple classes, right? Only then you can come up with a base class. When there are 3 or 4 classes you have in your program, and if you have to decide the inheritance, you need to identify, because base class is something which has the common functionalities, right? If for example, loan class has housing loan class, business class, consumer class, personal loan class, etc. Fine. These are all the subclasses of loan or subtypes of loan. So when I say subtypes of loan, these are all become the derived class of loan class. And when you consider or when you are designing the class diagram, when you are deciding which one is the base class, which one is the derived class, generally the base class will have the common functionalities. Loan is a general class, right? But when it comes to a housing loan or a car loan or a personal loan, they are specific, right? They will have some specific features, but they use the functionalities of loan class. So when all these three, housing loan, car loan and personal loan, derive the loan class, this loan class is supposed to be general in nature. That means that should be applicable even to the housing loan or the car loan or the personal loan, right? So that should be a what we say, a similar function, similar to these three derived classes should be included in the loan class. So it is very important you identify the similarities among the different classes so that you can design a base class, right? So the process of identifying the similarities among different classes is called as generalization. Okay, coming up with the general class. So what is common in all the three classes, like housing loan class, the car loan class, personal loan class or business loan class? In all these four classes, what is common? So these common things you extract and put it in one class, and that will become a base class. Okay, or that will become a general class. Fine. So the class which is identified after generalization is called as the base class. Fine. So you find out the generalization first, that is you group the similar attributes, the similar features of all the classes, and that becomes a base class. Fine. And the classes over which generalization is made are called the derived classes. You consider housing loan class, car loan class, personal loan class, and business loan class. You extract the similarities and you put it in one class, that will become the base class. And to use or to construct the base class, whatever the classes you have used are called as a derived class. So housing loan class, car class, business loan class, personal loan class, these are all become the derived classes. Okay, that is the concept of generalization. And the classes over which the generalization is built, that is called as the derived classes, or is nothing but the specialization. Okay. So process of creating classes for specific need from a common base class. Housing loan is a kind of specialization. It is a special class which is specifically designed for offering the housing loan. Similarly, business loan is a specific type of loan which is only for business purpose. Okay. But if you consider the base case or base class, which is a loan class could be a housing loan class, could be a business loan, or could be a personal loan, right? That is why that is a general class. This housing loan, business loan, personal loan, car loan, these are all become the specific classes or derived classes. Okay. So the generalization, to be simple, generalization identifies common attributes and common behaviors among different entities, I can say, whereas specialization identifies the distinct attributes and behaviors, okay, which differentiate a derived class from another class. Housing, in order to differentiate a housing loan and a business loan, there should be some unique behaviors or unique functionalities included in them, right? That identifies, that gives you the specialized behaviors. Okay. So for example, loan class in the loan system is an example for generalization because it is a base class. Okay. So common attributes or common behaviors included in the loan class could be, for example, you have loan amount, interest rate, duration, and customer ID. These are all included in the loan, and they are common for any type of loan you consider, right? Loan amount, whether it is a housing loan, car loan amount is mandatory. Similarly, interest rate. So all types of loans, interest rate will be there. Duration, and every loan should have a customer ID. Okay. But when you are taking a housing loan, there will be an option to specify the interest type. Similarly, when you are taking a business loan, there is an option to specify the term and interest type. Similarly, consumer loan will have a specific variable or special variable called product name. They are not common to all the three types of loans, right? They are different. So that is about the generalization and specialization. Fine. So the classes corresponding to various types of loan are the examples of specialization. That is housing loan, business loan, large business loan, consumer loan. These are the examples of specialization. Loan class is an example for generalization. Any doubts? This is an example. The diagram you can see the example of generalization and specialization, or a class diagram representing generalization specialization hierarchy for the loan system of global consumer or global commerce bank. It is global commerce bank, right, in the case study. So that class diagram is shown here in the slide. Any doubt? Generally, identifying this base class and derived class, or identifying generalization and specialization for any case study or for any problem statement given to you, helps in removing redundancy of code. Okay, when you actually implement, instead of having the common functionalities included in multiple base derived classes. When you group it in a single base class, that removes the redundancy of code. Okay, redundancy in the code. That is very important. So the concept of generalization and specialization plays the major role when you are designing any real world application using object oriented concepts. Any doubt here?
No, ma'am.
Oh,
All right. So this is about important topic of object-oriented concepts, that is inheritance. We are not discussing much code in it because of course, some of you might be interested in coding. You can contact me. Okay, I will help you out with the coding. But the reason for not discussing much coding here is you are from a different background, not from computer science background. And when we explain you these concepts in program terms, you might find it difficult to understand. Not all, but there are some students who are not into programming and you might find it difficult. That is why the programming concepts are depicted in the pictorial form here. Okay, the class diagram, I can either represent it in the form of a class diagram or in the form of a code. Okay, a program. So among these two representation, I chose the class diagram so that I could convey the concept to the entire class, not just one set of students who are good in programming. Okay, but again, if you are interested to actually implement them, you can contact me. Okay, you can message me in the personal chat and I can provide you the help. Fine. Okay. There is another important feature of object-oriented concepts that is called as polymorphism. Okay, polymorphism is a feature which helps to extend the functionality of an object. Okay, or the class functionality. So the polymorphism meaning is poly means many, morph means form. So polymorphism refers to the object's ability to behave differently, okay, depending on its type. One object, multiple forms. That is a meaning, okay. So one object based on its type, it can behave differently. That is why the name polymorphism. And this particular feature of object-oriented concept provides a means to extend an object's functionality. Okay, we will study anyway in detail, we will study this. So, polymorphism brings two important features to objects. Okay, they are method overloading and method overriding. Fine. Method overloading is also called as function overloading. Method overriding is also called as function overriding. And there are two kinds of polymorphisms, namely static polymorphism and dynamic polymorphism. In static polymorphism, what happens is the function call or the binding of function call to function definition is done during compile time. You know that there will be function definitions where the actual function is implemented, and in some other class or in some other function we can make a call to that particular function, defined function, right? So the time where this binding happens, when you make a function call, the binding of that function call to function definition happens during compile time in case of static polymorphism, and when it happens during runtime it is called as dynamic polymorphism. Okay, so when your program is executed and your execution control reaches the function call, okay, if that binding of function call to function definition happens during compile time, then it is called as static polymorphism. And if that binding happens during runtime, it is called as dynamic polymorphism. Okay. Function overloading is nothing but the implementation of static polymorphism where function call is bound to function definition during compile time. Whereas in case of function overriding, it is an implementation of dynamic polymorphism. That is during runtime, function call is bound to function definition. Okay. All the object-oriented concepts or object-oriented languages implement the concept of polymorphism. Okay, all C++, Java, uh, C hash, all these languages, okay, use the concept of polymorphism. So polymorphism means one object behaving differently, right, at different situations, different circumstances. And there are two features of polymorphism. Basically, they are method overloading and method overriding, and they are very, very important concepts of OOP. Okay, and there are two kinds of polymorphism: static polymorphism and dynamic polymorphism. And the type of polymorphism is decided based on the time where function call is bound to function definition. If it happens during compile time, then the polymorphism is static. When this binding happens during runtime, the polymorphism is dynamic. And based on the type of polymorphism, either method overloading or method overriding is used. Okay, when the concept is static, the implementation of this polymorphism is called as method overloading. When it is dynamic, when the polymorphism is dynamic, its implementation is called as method overriding. Any doubt here? Any doubt?
No, ma'am.
If there is no doubt, I'll stop the class now. Okay, because method overloading and method overriding we need to explain with the help of a function, okay, a simple program, and that might take time. Okay, so I will stop the class for the day, and we'll continue in the next class. Any doubts you can ask me.